All right, section 3.2, linear functions, part 2. So today we're going to get to the second half of 3.2 linear functions, which basically is these last two objectives. We're going to graph linear functions using discrete and continuous data, and we're going to write some real life problems to fit some data. So let's go ahead, let's jump to our notes where we ended up last time. Okay, maybe. All right, we'll do it this way. All right. Okay, so we ended up here representing linear functions from the equation, and that leads us to different ways to represent functions. Functions can be represented in a lot of different ways. First, we can represent it using words. For example, I could just say an output is 3 more than the input. Okay, so the output is 3 more than the input. Okay, so I could write it in words. Or I could write it as an equation. So here we say we have an output. Well, our output is predominantly y. Is normally is an equal sign. And then we want 3 more than the input. So we want to take the input and add 3. So we're going to take the input and add 3. Okay, so there we have the output. This is just telling us the output is 3 more than the input. Okay, so there's one way. So there we have two ways. We could use it as words. We could do it as an equation. We could do an input-output table. So we could have input, here is x, output, here is y, and I could put numbers in. So let's put in, if I put in a -1, -1 plus 3 is 2. I could put in a 0, 0 plus 3 is 3. I could put in a 1, 1 plus 3 is 4. I could put in a 2, 2 plus 3 is 5, and so forth and so on. Okay, so I could also, so there's an input-output table, still representing this same function. These are all the same function, they're just different ways of writing them. Okay, I could do a mapping diagram. I could have an input map, and that would be my -1, my 0, my 1, and my 2. And then I could have my output map, and that would be my 2, 3, 4, and 5. And then I would say, okay, my -1 goes to 2, my 0 goes to 3, my 1 goes to 4, my 2 goes to 5. Show which one goes to which. Okay. But I also could graph these. I could think all of these as ordered pairs. We have the ordered pair -1, 2, 0, 3, 1, 4, 2, 5, and I could graph these. So -1, 2, 0, 3, 1, 4, 2, 5, and these aren't the only numbers that will work, and so actually it would be this line that connects them. Okay, so I could do it as a graph because any of these points on this graph will work. This point down here will work, this point down here will work, this point here. Any of these points on that line, even these in-between points, I could put a half in and get 3.5. I could put 1.5 in and get 4.5, so forth and so on. Okay, so these are all different ways of representing a function. Okay, excuse me. Now, the solution of a linear function in two variables. When we talk about a solution, we're talking about any of the ordered pairs, that make the equation true. Okay, so if any of the ordered pairs, so over here, these were all solutions of this equation. -1, 2, 0, 3, oh, let's get rid of that mark, 1, 4, 2, 5, these all here were solutions. Now, when I look at all of the possible solutions, and I graph them, meaning I plot all of the ordered solutions, then we get the graph. The graph of a linear function is the set of points that represent all of the solutions. Okay, so like in this one over here, this had an infinite number of solutions because any of these points along here would work. So any of these were solutions. Okay, so this graph is a picture of all of the possible solutions. Okay, hey, and this isn't a good example of what we call a continuous domain, because the domain is any number here and every number in between there. So a continuous domain, we have two different types of domain. A continuous domain, okay, would be any of the numbers in between two numbers. Okay, so for example, if I was looking at the numbers from 1 to 5, and I was looking at all the numbers in between 1 to 5, it would be any of these numbers. So it would be like the number 2, 3, but it would also be the number 2.1 and 4.9 and 3.5. And any of these numbers in between would be a continuous domain. Okay, so it's all of the numbers in the interval. Whereas a discrete domain, okay, is just only certain numbers in an interval, or just only certain numbers in general. Okay. For example, a discrete domain between 1 and 5 would just be the numbers 1, 2, 3, 4, and 5. If you notice, none of these in-between numbers in here are shaded. So we're just talking about the numbers 1, 2, 3, 4, 5. So here, to list a discrete domain, we would just list the numbers 1, 2, 3, 4, and 5. Okay. To list a continuous domain, we would have to use our inequalities. So we could say, we could do it in words, all numbers from 1 to 5. Or we could go 1 less than or equal to x less than or equal to 5. So we could list them there as our inequality. Okay. All right.